Bismillahirrahmanirrahim. Assalamu-Alaikum Guys. My dear students, this is Muhammad Asif Qureshi, working as assistant professor of chemistry at Government Biology College, Assalam-U-Alaikum Hyderabad. Today we are together here for a new lecture from the syllabus of first year chemistry, and this particular lecture I have taken from a very important chapter of first year syllabus, chapter number 3, the atomic structure. Although overall this is the fourth lecture from the syllabus of first year chemistry, but from this particular chapter, this is the first topic which I have selected because it's a very important topic to be discussed today, and that is electronic configuration. You must know and realize it that this particular topic is not only important regarding your first year chemistry syllabus, but whole of your intermediate syllabus which you will be studying in your upcoming year will be based upon this particular topic, particularly the inorganic chemistry syllabus, S block elements, P block elements, D block elements. They are entirely based upon the electronic configuration of elements. So this is a very important topic. Be focused, be concentrated towards the board and towards the things which I am going to illustrate or explain to you right now. If one thing I must tell you, that this topic I have divided into two parts. This lecture I have divided into two parts. The first part which I am talking on today is the first rule of the electronic configuration, Aufbau principle, and the remaining rules or principles will be discussed in the second part of this lecture. Before going through the Aufbau principle, I must go through the definition of the term electronic configuration. Dear students, electronic configuration is the process by which we distribute the electrons among various subshells of an atom. The distribution of electrons among various subshells of an atom is called electronic configuration. Now, as I told you earlier, that there are various rules or principles for building up the electronic configuration of the elements. Out of which the first one, the basic principle, is the Aufbau principle. Aufbau principle was given by Linus Pauling. The scientist named Linus Pauling gave this principle. The term Aufbau has been derived from German language, which means building up in English. And this principle, as I told you, that it was given by Linus Pauling. The statement of the principle says, the statement or definition of this principle says, the electrons in an atom are distributed in the order of increasing orbital energy starting with the 1s orbital. This is the simple statement of the Aufbau principle, which says that if you are going to distribute the electrons in the atom, you have to start filling up electrons in the very first orbital, very first shell. The first shell is K shell, and in K shell there is only one orbital, S orbital, so you have to keep filling the electrons starting with one S orbital. First shell will be filled, then the second one, then the third one, and so on. So this is the basic principle, Aufbau principle, whose statement says that electrons in the atom are distributed in the order of increasing orbital energy, starting with the 1s orbital. Now, to explain this principle, there is a simple game which I want to play with you people, and that is a very interesting game, simple and interesting. Hopefully, you will be understanding that. Dear students, these are the values of principal quantum number, and principal quantum number, you must be knowing that symbol of principal quantum number is small n, and its value ranges from 1 to 7, for which we represent different shells. If principal quantum number value is 1, it represents K shell. Then comes the L shell, M shell, N shell, O shell, P shell, and for N7 it must be Q shell. In K shell there is only one orbital, which is the s orbital. In L shell there are two orbitals, first one is s and another one is p. The third shell N comprises of three orbitals, s, p and d. Fourth shell N has four subshells, four orbitals, s, p, d and f. As you all know that s orbital has only 2 electrons in it. P orbital contains 6 electrons, d orbitals 10 electrons, and there are 14 electrons in the fourth orbital, which is the f orbital. Now, if I write the order of filling electrons, by following Aufbau principle. Dear students, I must tell you here that Aufbau principle is the basic principle which represents the ground state configuration for the elements. Now, the first 2 electrons will be allowed to enter in the s orbital of the first shell. So I must write here, first is the number of shell, s will be the subshell, and 2 is the number of electrons which will be entered into the s orbital of first shell. Then, following the second arrow, again 2 electrons will be entered into the s orbital of second shell, L shell. So you must write here 2s2. It shall not be read as 1s square 2s square, rather it will be read as 1s2 2s2. Then following the third arrow, now 6 electrons will be entered into the p orbital of second shell. You will be writing here 2p6, followed by the 2 electrons of s orbital in the third shell. It will be written as 3s2. Again 6 electrons will be entered into the p orbital of third shell, followed by 2 electrons in the fourth s orbital. So we write here 3p6 and 4s2. Then following this arrow, 10 electrons will be entered into the d orbital of third shell, followed by 6 electrons in the 4p and 2 electrons in the 5s orbitals. So we write here 3d10, 4p6, 5s2. Then 10 electrons in the 4d, 6 electrons in the 5p, 2 electrons in the 6s. So we write here 4d10, 5p6, 6s2. Now 4f14, 5d10, 6p6, 7s2. This is the simple order of filling electrons among various shells and subshells of the atom following Aufbau principle. Now, if I give you some examples for the building up of electronic configuration, say for example, if I say you are asked to write the electronic configuration of sodium whose atomic number is 11, you must follow Aufbau principle to distribute these 11 electrons. You must write 1s2 here, 2s2, 2p6, 3s1. 1s2 shows that K shell is complete. 2s2, 2p6 shows that L shell contains 8 electrons and it is also completed here. While the last shell is M1 and our M shell contains only 1 electron in the s orbital here. So this is the way you can write the electronic configuration of sodium atom. This was atom, it was having no charge. But if I write potassium ion here carrying monopositive charge on it, it shows that out of total 19 electrons, potassium has lost 1 electron. So the remaining electrons which have to be filled here is 18. Now 18 electrons in the potassium ion are filled as following this Aufbau principle: 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. This is the K shell, L shell, M shell, and the last one is N shell, which contains only 1 electron. Okay. 1 electron it has lost because I write positive ion charge on it, so it will not be mentioned here. 18 electrons in all we have to add here. So 2, 4, 10, 12, 18 electrons. This is the configuration of potassium monopositive ion. Similarly, the last example which I am giving to you is of fluoride ion. And fluoride ion is mononegative ion. It has minus charge on it. Minus charge on the fluorine shows that it has gained 1 electron. It was having its own 9 electrons. 1 more electron it has gained. So now we have to fill 10 electrons in all in the fluoride ion. Following the above principle, I must write here 1s2, 2s2, 2p6, K shell complete, L shell is also complete. If this negative charge would not have been there, the configuration to be written would be 1s2, 2s2, 2p5. But as you all know that I put minus sign over fluorine atom, so showing that it has gained 1 electron. Now it will not be written as 2p5, rather it will be written as 2p6, showing that now it has become 10 electrons. It has got 10 electrons, 1 electron it has gained. So in this way you can build up the electronic configuration following Aufbau principle of various atoms of ions. My dear students, here I am leaving today the first part of this lecture, electronic configuration. Inshallah, in my upcoming video lecture, you will be having the remaining rules to be discussed there. the N plus L rule, the Hund's rule, Pauli's exclusion principle for the electronic configuration of elements. Hopefully you have understood all the things which I have explained. Khuda Hafiz for today. Inshallah we will be meeting in the upcoming video lecture. Thank you. Khuda Hafiz. Assalamu alaikum wa rahmatullahi wa barakatuh.